Hello guys, welcome back to our YouTube again with another video. Today I'm going to explain you all about half-range sine series for the given function f of x equal to x cos x in the interval 0, pi. So let's have a look at the problem and the solution now. Find the half-range sine series for f of x equal to x cos x in the interval 0, pi. So let's have a look at the solution now. Solution here. So given f of x equal to x cos x. So f of minus x equal to minus f of x because minus x cos x. Minus x cos x is here x cos x is f of x, so it's an odd function. So f of x is odd function. So next we should find it is in the interval 0, pi. So interval 0, pi. So L value is equal to pi. Equal to pi. L equal to pi here. So next we should find f of x value. F of x equal to summation n equal to 1 to infinity bn cos no for sine series we should take sine n pi x by L. Here pi will be equal to L. So pi will be cancelled out. It will be summation n equal to 1 to infinity bn sine nx. So bn value here. Bn value equal to uh, integral 0 to pi 2 by pi f of x is what here x cos x into sine n pi x by L. L is what here pi. So pi will be cancelled out in x. So 2 this 2 this cos x sine nx will be taken as 2 cos x sine 2 cos a 2 cos b sine a equal to sine of a plus b plus sine of a minus b. So here we'll take so here this first term will be taken as a, this second term will be taken as b, integral of these two. So here a equal to integral 0 to pi here 2 by pi will be taken as common here dx here. So a equal to x cos x sine nx sine nx n plus 1 into x. Here we should substitute n plus 1 and x in the formula of sine of a plus b. Yeah. So we'll get x into sine of a, n plus 1 x plus sine of, it will be not taken, it will be taken as b. So first we should find x sine n plus 1 into x. So here uh, x is what here, so x, write it as x. So sine integration is cos minus cos, so minus cos n plus 1 into x by 1 plus n, 1 by n plus 1. So next we should find next is minus, this is by Bernoulli's Bernoulli's integration by parts formula. Bernoulli's integration by parts formula is what, uv dx equal to uv1 plus uv1 minus u dash v2 for x where x degree equal to 1, there x degree equal to 1 n plus 1 terms. This is the formula for integration by parts by using Bernoulli's equation, Bernoulli's integration principle. So here next minus x into 1 by n plus 1 whole square sine of n plus 1 x in the interval 0 to pi. So here n plus 1 pi is what here, sine of n plus 1 pi equal to 0. Sine of sine 0 is also 0. So this total term will become 0 for the interval 0 to pi. Next, in this term we will write it as minus pi integral cos n plus 1 pi. Cos n plus 1 pi is what here? So here cos n pi equal to minus 1 whole power n. So cos n plus 1 pi equal to n plus 1 minus 1 whole power n plus 1. So here minus 1 into minus 1 whole power n. So minus of minus 1 whole power n. So here it will be minus of minus 1 whole power n. So here it will be minus into minus will become plus. So by n plus 1. So here is the first equation. So here next we should find a second. Here minus into minus will be plus. Here also plus. It will be pi by minus 1 whole power n by n plus 1. So this is the equal to a here. Next we should find b value. So for finding b value, you can write it as b equal to integral 0 to pi x sine n minus 1 into x dx equal to same here only. We should change the sign as n minus 1. So here minus x cos n minus 1 into x into n minus 1 minus this term minus x by n plus 1 whole square n minus 1 whole square sine of n minus 1 into x under the limit 0 to pi. So 0 to pi. So answer will be here minus pi here plus minus of minus is plus. So here cos of n minus 1 pi is also value is cos of n minus 1 pi equal to minus 1 whole power n minus 1 equal to minus 1 whole power n by minus 1 equal to minus 1 whole into n minus 1 n. So here it is also same. So here plus pi into minus 1 whole power n by n minus 1. So this is b. Adding b and a. So here bn equal to pi into minus 1 whole power n by n minus 1 n plus 1 plus pi into minus 1 whole power n by n minus 1. So your answer will be pi into minus 1 whole power n into 1 by n plus 1 plus 1 by n minus 1. So your answer will be 2n by 2 minus 1 whole power n by n plus 1 into n minus 1. So this is bn value. Next we should find out f of x value. In the next page we can find it out. So here is a small mistake. Bn equal to 1 by pi integral 0 to pi x cos x sin nx dx. This can be written as 0 to pi x sine of n plus 1 into x plus sine of n minus 1 into x. So here x is multiplied to both n sine of n plus 1 into x and sine of n minus 1 into x. So here 1 by pi was left here. So write it 1 by pi here. So here is the in the bn value we should write it as 1 by pi here. So pi will be cancelled out. Here also pi will be cancelled out. Here also pi will be cancelled out. Here also pi by pi is cancelled out. So here answer will be, we will see in the next page. So here bn value is equal to 2n into minus 1 whole power n by n square minus 1. So here a plus b into a minus b was what here is a square minus b square. So here n square minus 1 equal to 1 square equal to n square minus 1. So I write it n square minus 1 here. So next f of x equal to, summation n equal to 1 to infinity bn sine nx nx. Sine n pi x by l is what here? N pi x by l is n pi x by pi. So pi pi will be considered. We will get nx. So this is nx I wrote here. So here b1 b1 sine nx plus summation n equal to 2 to infinity bn. Bn is what here? Bn is 2n into minus 1 whole power n by n square minus 1 sine nx. If we substitute if we want the value of b1, we will get 2 into minus 1 uh, 2 into 2 into minus 1 whole power n by n square minus 1. So here answer will be 2 into minus 1 by 1 minus 1 equal to 2 by 0 equal to infinity. So b1 can't be infinity here. In the Fourier series expansion, b1 can't be infinity. So here we will write we will directly substitute bn value in the integral we have solved in the first page. So here is the integral b1 equal to 2 by pi integral 0 to pi x cos x sine 1 plus uh, 1 sin x dx. So here we will write it as in the page, next page. So here 2 b1 equal to 2 0 to pi by pi x cos x sine into 1 x dx equal to 2 by pi 0 to pi x cos x sin x dx. 2 sin x cos x equal to sin 2x. So 1 by pi into 0 to pi x into sin 2x dx. Since 2 sin x cos x equal to sin 2x, I substituted here in this formula. So here 1 by pi into in the interval 0 to pi, I am applying Bernoulli's integration by parts formula. X into 1 by 2 minus cos 2x minus minus x minus 1 sin. So here first thing will be positive and second thing will be negative in the Bernoulli's equation of integration by parts. So here sin 1 by 2 sin 2x and the intervals 0 to pi. So here 1 by pi into this total term will be 0 because sin 2 pi value is 0. So here minus pi 1 by 2 cos 2 pi. Cos 2 pi value is what here? 1. So here 1. So here cos 2 pi value is 1. Pi pi will be considered. Answer will be minus 1 by 2. So here next we should find a b1 value. F of x value. F of x equal to minus 1 bn minus 1 by 2 sin x bn equal to minus 1 by 2. So here it is minus 1 by 2 here. So next plus integral here, see here. So first term will be this series will be expanded up to 2 into 2 into 1 by 3 4 by 3 plus 6 into minus 1 by 9 minus 1 equal to 4 by 3 plus plus into minus will be minus 6 by 8 and so on up to infinity. So the term will be like this. So or we can write it as like this: summation n equal to 2 to infinity 2n into minus 1 whole power n by n square minus 1 sine nx. So this is the solution for the given function f of x. This is the half range sine series for the given function f of x. So this is the solution. If you like the video, please subscribe to my channel, hit the like button and the bell icon and activate the notification bar. Thanks for watching, friends. Bye. Thanks for watching.